Hello everyone. In today's video, we are going to discuss about the Ford Fulkerson algorithm. Note that the objective of the Ford Fulkerson algorithm is to find the max flow maximum flow in a flow network. Now, to understand what do you mean by a flow network, please go through my previous video wherein I have discussed about what do you mean by a flow network, what is a flow, what do you mean by the residual capacity as well as the augmenting path. Maybe in my previous video, I have stated that in order to find the max flow in a flow network, I need to find the augmenting path in the residual network. Now, if there is an augmenting path in the residual network, then we can calculate the max flow. If there are no augmenting path, then it implies that we have calculated the max flow. Now, the algorithm which is based on the augmenting path is the Ford Fulkerson algorithm. And this algorithm is also called as, sometimes it is also called as augmenting path algorithm. To find the max flow, and the person who have invented this algorithm are Ford and Fulkerson in the year 1956. Hence, it is being named as the Ford Fulkerson algorithm. Now, the input to this algorithm, as we know, is a flow network denoted with G and a source vertex denoted with S and the sink vertex denoted with T. Now, the first step of the algorithm, on all the edges, I will initialize a flow to be 0. That means I will initialize flow F to be 0 in the first state. Then I find whether there is an augmenting path or not. If the flow is 0 on all the edges, obviously there have to be an augmenting path. At least there have to be one augmenting path. So, while there exists an augmenting path P in the residual network GF, now what we will do, I will add the bottleneck capacity to my final flow. That means I am going to augment flow F along P. I keep repeating this until and unless there is an augmenting path in the residual network. If there are no augmenting path in the residual network, then it implies that I have calculated my maximum flow. So, in the fourth step, I have written the max flow denoted with F. So, this was about I can't call it as an algorithm because I have not mentioned how to augment flow F along the path P. Hence, it is being mentioned as a Ford Fulkerson method. We'll take one example and we'll trace how exactly this Ford Fulkerson works on the given graph, and then we'll rewrite this Ford Fulkerson method and we'll call that particular pseudocode as the algorithm of the Ford Fulkerson. Hope it is clear. We'll take an example to understand better how the Ford Fulkerson algorithm works. In order to trace how Ford Fulkerson algorithm works, I have taken a small graph with 6 vertices with the source vertex denoted with S and the sink vertex denoted with T. Now, what was the first step? First step was I will initialize flow to be 0. Here, my flow value is being initialized to 0. In the sense, on all my edges, I can associate a flow as 0. What is the next step? Second step is I need to find an augmenting path. Now, assume that if my flow is 0, then it implies that on all the edges, my flow value will also be 0, and this will be my residual graph. So, in the residual graph, I need to find the augmenting path. Now, I'll first go for the first augmenting path. Let me call the augmenting path as P1. Now, which to be considered as augmenting path? You can take any of the augmenting path. Now, I'll be a little bit greedy. I'll go with augmenting path S to V1, V1 to V2, and V2 to T. Why I have taken this? Because I know that what is the bottleneck capacity on this? The bottleneck capacity is the minimum of these three. Minimum of these three is 12. Now, what I need to do? I need to associate V1 Now on the edge S2 V1 I will have 12 as my flow. Next in this I will have 12 as my flow. Here I will have 12 as my flow. All other things no change. Its direction is from V2 to V3. 14, 7, 4, 13. Now on considering this, what was my flow? Flow is now increased from 0 to 12 because I am having 1 units of data coming towards T. Now write the residual network for this. How to write the residual network? If you are watching the video for the first time, please go and visit my previous video how to construct the residual network. How to construct the residual network? Yes. T, V1, V2, V3, V4. The edges that are not a part of my augmenting path will remain same. No need. Only those edges which I have considered I need to change. S to T 12 units. So there will be a forward edge as well as there will be backward edge. Forward edge is 16 minus 12, 4. Backward edge is the flow. That is 12. Now flow and capacity both are same. Hence I can have only backward edge. Next 20 minus 12 is 8. So in the residual graph 8. This will be 12. So this is the first step. If I am considering the augmenting path P1 with a bottleneck capacity 12, I have my flow as 12. Next, I'll go for the next augmenting path. I need to check whether there is an augmenting path in my residual network. This is my residual network. Is there an augmenting path? Is there an augmenting path? What is this? 13. This was 14. Now I'll consider this S to V3, V3 to V4, V4 to T. So I'll consider the second augmenting path P2 as S to V3, V3 to V4, V4 to T. Now what is the bottleneck capacity of this? This is 13, 14 and 4. Minimum is 4. Yes. V1, V2, V3, V4 and T. I need to update only this edges. All the other edges I will have as it is. This was 8. This was 12. This was 7, 9, 4. Now I have considered this edge S2 3. So on S2 V3 flow is 4 of 13. Next is 4 of 14. Next 4 of 4. 4 of 4. I'll rub this. Now with this what I have done, the earlier flow was 12 plus 4, I have increased it to 16. 12 plus 4 I have increased it to 16. Now I need to have the residual graph for this. Yes. T, V1, V2, V3, V4. This 4 to V3 forward edge, 13 minus 4, 9, 4 here, 14 minus 4, forward edge 10, backward edge 4. This is full, so this will be a backward edge of cost 4. Other things 7, 9, 4, 12, 8 and 12. this was 4, this was 12. So this is my residual network GS. Now I need to find whether there is any augmenting path in this residual network. Now I will go with S to V1. Now from V1 there are no outgoing edge. Now I will just check with S with V3, S with V3, V3 with V4. From V4 to V2, V2 to T, there is a path. So I'll consider, what was it? V3, S to V3, V3 to V4, V4 to V2, and V2 to T. Now this was 9, 10, 7, 7 and 8. 9, 10, 7 and 8. What is the bottleneck capacity? Bottleneck capacity is 7. Is 7. So yes, T, V1, V2, V3, V4. And this edge needs to be considered. We'll update later. 4. Backward edge, no change. Backward edge, no change. Now on this forward edge from S to V3, I should take the bottleneck capacity as 7, 7, 9, 7, 10, 7, 7, 7, 7, and this is 8, 7. This is 12. Now what I have done, the flow is being increased by 7, sorry, this was 7, 8. It was earlier 16, 16 plus 7, 23. 23. Now write the residual graph once again. The edges that I have considered are this. So no change here. Now what about this? 7 units. 9 minus 7 is 2. 2. Add this 7 in the backward edge. This will be 11. Now 7, 10 minus 7 is 3. Forward edge is 10. Sorry, forward edge is 10 minus 7 is 3. And add this 7 to 4. So in the backward edge it will be 11 once again. Next, this is 7 out of 7. So there will be a backward edge of cost of capacity 7. Here this is 4, and this will be forward edge with 1, and the backward edge I need to add this 7 to 12. This is 19. So this is my residual network. Now find whether there is an augmenting path. So from S to V1, from V1 I can't proceed further. S to V3 I can come. From V3 I can go to V1. From V1 I can't go. S to V3. From V3 to V4 I can go. From V4 I can't reach T. From V4 I can't reach V2 also. So there are no augmenting path. So this is I need to stop here. So my max flow is 23. This was about the tracing of the Ford Fulkerson algorithm. Now we will go for the elaborated Ford Fulkerson algorithm, and we'll see what is the time complexity of the algorithm. This is the full-fledged Ford Fulkerson algorithm. Note that the algorithm has same 3 inputs: graph the flow network G, source denoted with S, and sink denoted with T. Now what was the first step that we did? The first step was we used to initialize the total flow to be 0. How it can be done? You assign a flow value of 0 to all the edges. So for each edge UV which belongs to G dot E, flow for all the edges is being initialized to 0. Next, we founded whether there is a augmenting path. Augmenting path, what is the augmenting path? It is a path from source to T. So while there exists a path P from source to sink, in the residual network GF. Note that we are supposed to find the augmenting path in the residual network GF. So what we did was we calculated the bottleneck capacity. How to calculate the bottleneck capacity? Bottleneck capacity is also termed as the residual capacity on path P. So the residual capacity on path P is equal to minimum of all the edges that are taken into consideration in the augmenting path P. Now we need to add the flow on all those edges. For each edge UV in P, if UV belongs to E, then what I have done, I have added the edge, I have added the flow, I have increased the flow on all those edges. If not, the edges are not, if the edge is there, then if the edge was full, you saw that in the reverse direction, that means V to U of F is equal to flow on V to U minus the residual capacity on the path P. This was explained in the previous video while calculating the residual capacity. That means if flow is less than the capacity, then I need to have the forward edge. If flow is greater than 0, we had two things. I need to have the forward edge also, as well as we need to have the backward edge. This is about the backward edge flow. Hope this is clear. This was about the Ford Fulkerson algorithm. Now coming to the time complexity of the Ford Fulkerson algorithm. Anyway, this first step here, for each edge UV which belongs to E, UV dot F is equal to 0. This is this takes a constant time. It depends upon the number of edges. Rather than saying constant time, I call it as order of E. Depends upon all the edges. Now, while there exists a path P from S to T. Now, this step is very important. How much amount of time we are spending in finding the augmenting path from S to T. It depends upon what search algorithm I am using. As we know that in case of graph, we have two popular search algorithms, DFS and BFS. Both have the time complexity of order of V plus E. Order of V plus E. Obviously the number of edges are quite more in case in any graph. So what I will do, rather than taking it as order of V plus E, I'll write it as big O of E. So assuming that this steps take order of E times, now how much amount of time we are spending in this? Now what actually this step does is, this whole step calculates the max flow. It calculates the max flow. Now we have denoted the max flow as F. Now note that in the worst case, on considering an augmenting path, the max flow can be increased by how much? It can be increased by only 1 unit. If the bottleneck capacity is just 1 on that particular path, then in worst case, I increase the flow by 1 unit. So this entire thing calculates the max flow. So I can say that this particular part takes order of F time, F or F star. In case of Foreman, he has given it as F star. F star is nothing but order of F. It is nothing but order of F. Hence, the total time complexity is big O of E into F star, or I can write it as F, where F is the max flow. So this is the time complexity of the Ford Fulkerson algorithm. Thank you.